What is matter really? You are not actually touching anything right now. That sounds impossible, because touch feels like the most obvious thing in the world. Put your hand on a table. Let it rest there for a moment. Press down slightly. You feel pressure in your palm. You feel firmness pushing back. It feels solid, stable, reliable. It feels like your hand has reached a surface, a boundary, something physical, something made of stuff. But that feeling is not quite what you think it is. What you are feeling is not contact in the simple way we imagine contact. It is resistance. Something is stopping your hand before the atoms in your hand and the atoms in the table can overlap. That is the first clue. Matter feels solid, but solidity is not the same as substance. Solidity is a behavior. It is what happens when structures resist being pushed into each other. And to understand that, we have to go much deeper than the surface of the table. In the last videos, we saw that light is not a little object flying through space. It is a pattern moving through a field. And energy is not a substance hidden inside things. It is a way of tracking change in a system. So now we can ask the next question. What is matter? Because matter feels different from light and energy. Matter feels like the obvious part of reality. The table, your hand, the chair, the ground, your body. These feel like the things that are really there. But physics has a strange habit of taking the most obvious things in the world and showing us that they are not obvious at all. So stay with the feeling in your hand. Press down again. But this time, do not think about the table. Do not think about wood, metal, plastic, or surface. Just notice the sensation itself. Where is it? Is it exactly at the boundary between your skin and the table? Or is it spread through your hand? Notice how the pressure is not a single point. It spreads across your palm. It changes inside your skin. It increases the harder you press. That already tells us something important. Touch is not a simple meeting of two surfaces. Touch is a response inside your body caused by an interaction with something else. Your nerves do not report contact directly. They report pressure, stretch, compression, vibration, temperature. Your brain turns those signals into the feeling of a solid world. And most of the time, that story works perfectly. It lets you pick up a cup, open a door, walk across the floor, and live in the world. But at the deepest level, the story is incomplete. Because when we zoom in, the solid surface disappears. Your hand is made of atoms. The table is made of atoms. And atoms are not tiny, solid balls packed together like grains of sand. An atom is mostly space. This is one of the great shocks in the history of physics. In the early 20th century, many scientists imagined the atom as something more like a tiny filled sphere. Then Ernest Rutherford and his students, Hans Geiger and Ernest Marsden, performed an experiment that changed the picture completely. They fired tiny, positively charged particles at an extremely thin sheet of gold. If atoms were solid, those particles should have been scattered everywhere, like bullets hitting a wall. But that is not what happened. Most of the particles passed straight through the gold, as if almost nothing was there. A few were deflected, and a tiny number bounced back at sharp angles. Rutherford later said it was almost as incredible as firing a 15-inch shell at a piece of tissue paper and having it come back and hit you. That experiment revealed something extraordinary. The atom is mostly empty space, with a tiny, dense nucleus at the center. If the atom were the size of a football stadium, the nucleus would be like a small grain near the middle. Everything else would be a vast region of space shaped by the behavior of electrons. So when you press your hand against a table, you are not pressing one solid wall of matter against another solid wall of matter. You are bringing two vast atomic structures near each other, mostly space, approaching mostly space, which gives us the real puzzle. If atoms are mostly empty, why doesn't your hand pass through the table? Why does the table stop you? Why does matter feel solid? The answer is not that atoms are secretly hard little balls. The answer is interaction. The outer regions of atoms are shaped by electrons. Electrons carry electric charge, and when the electrons in your hand approach the electrons in the table, they resist being forced into the same space. A simple way to feel the idea is with magnets. Take two magnets and try to push them together the wrong way around. They may not touch, but you feel resistance immediately. Something pushes back before contact happens. That is closer to the truth of touch than the idea of two solid surfaces hitting. Your hand is not crashing into the table like a rock hitting another rock. At the atomic level, it is being pushed away. The structure of your hand and the structure of the table resist overlapping, and that resistance is what you feel as solid. Now, there is a subtle but important point here. With magnets, you already understand that the feeling is interaction. You do not expect the magnets to merge together before they push back. You accept that something invisible is happening between them. But with your hand and the table, your brain tells a different story. It tells you there is a surface, a hard boundary, a thing. That story is useful, but it is not the full story. What feels like a surface is really the place where interactions become strong enough for your body to notice. That is why pressing harder changes the feeling. Press your hand down gently, and the resistance is gentle. Press harder, and the resistance increases. The table pushes back more strongly. That behavior matters. If matter were just stuff, we might imagine it as something simply being there. But what we actually experience is a response, a system pushing back against change. This is the deeper idea. Matter is not just what something is made of. Matter is what a stable structure does when another structure tries to pass through it. Now, take your hand away from the table and press your palms together. Slowly increase the pressure. It feels very familiar, but now it becomes easier to see what is happening. One hand is not fundamentally different from the other. They are both made of atoms, both mostly empty space, both structured by the same kinds of interactions. And yet, they do not pass through each other. They resist. Two structures maintaining their form, two patterns refusing to overlap. That is what solid really means. Not full, not packed, not continuous substance. Stable. Stable enough to hold shape. Stable enough to resist compression. Stable enough to push back. Now, pick up something near you, a mug, a phone, a pen, anything you can hold. It feels like one object, a single thing. But what you are holding is an enormous arrangement of atoms. In your hand alone, there are roughly around 10 to the 27 atoms. That is a 1 followed by 27 zeros. That number is so large that it almost stops meaning anything. There are more atoms in your hand than there are stars in the Milky Way galaxy. And every one of those atoms is part of a structure that holds together well enough for you to call it your hand. The object you are holding is the same, a vast atomic pattern. When you grip it, you are not grabbing solid stuff in the simple sense. You are creating a balance of resistances. Your fingers push inward. The object pushes outward. Friction helps stop it slipping. Your muscles adjust the force without you even thinking about it. Your nerves report pressure. Your brain turns that into the experience of holding something. If you loosen your grip, the balance changes. The object slips. Nothing about the object's substance suddenly disappears. What changes is the interaction. The same idea appears everywhere. Tap your finger on the table. A quick, sharp response runs through your skin. Tap harder, and the response is stronger. Tap with your fingernail, and it feels different. Tap with your knuckle, and it feels different again. Each sensation is your body detecting how structures respond to force. Touch is not one thing. It is many kinds of interaction translated into feeling. Now think about sitting in a chair. It feels like you are resting on a solid surface beneath you. But again, that is not quite right. Your body is being supported by countless tiny interactions. Atom by atom, structure by structure. Resistance balancing weight. Gravity pulls you down. The chair pushes back. Not because the chair is a magical barrier, but because its internal structure resists being compressed. This is why the material matters. A wooden chair resists one way. A cushion resists another. A metal bench resists another. A mattress allows more deformation before it pushes back with the same strength. The feeling changes because the structure changes. Solidity is not a single property. It is a relationship between force, structure, and time. Move your hand slowly through the air, and air feels like almost nothing. Move it quickly, and suddenly, resistance appears. Put your hand out of a car window, and the air pushes hard. The air did not become solid, but at speed, the interactions happen quickly enough and strongly enough that you feel them. Water is even more revealing. Move slowly through water, and it parts around you. Hit water quickly, and it can feel almost like concrete. Divers know this. A belly flop hurts because water cannot move out of the way fast enough, so the resistance rises sharply. So when we ask whether something is solid, we are really asking, how does this structure respond when something tries to change it? That is why steel can feel rigid, rubber can feel flexible, glass can feel hard but brittle, and water can feel soft or hard depending on speed. Matter is not one simple kind of thing. Matter is organized resistance. Now, let's connect this to energy. In the last video, we said energy is not a substance. It is a measure of change in a system. That idea matters here. To compress something, you have to change its arrangement. To bend it, you have to change its arrangement. To break it, melt it, stretch it, dent it, or tear it, you have to change how its parts relate to each other. And that takes energy. A table keeps its shape, because changing that shape requires energy. A spring pushes back, because compressing it stores energy in its structure. A rubber band snaps back, because stretching it changes the arrangement of its molecules. A steel beam holds weight because its internal structure resists deformation. So matter and energy are not separate ideas living in different worlds. Matter is structure that stores, resists, and channels change. Energy is how we measure the possible changes in that structure. This is why the phrase matter is energy can be misleading if we take it too literally. It is not that matter is a glowing substance called energy. It is that matter is a stable pattern in fields, and that pattern has energy. It can change. It can resist change. It can transform. Einstein's famous equation, E equals mc squared, revealed that mass itself is connected to energy. But even that does not mean matter is simply made of energy, like a material. It means mass and energy are deeply related properties of physical systems. That is subtle, but important, because the point of this series is not to replace one simple picture with another simple picture. It is to build a better mental model. Light is a pattern in a field. Energy is a measure of change. Matter is stable structure. Now, what does that structure actually look like at the deepest level? At everyday scales, matter looks like objects, tables, cups, hands, walls. At atomic scales, matter looks like nuclei and electron clouds. At deeper scales, even particles are not tiny solid marbles in the old sense. In modern physics, particles are understood as excitations of fields. An electron is not a little bead of substance. It is a stable excitation of the electron field. Quarks are excitations of quark fields. The electromagnetic field gives us light. So the world is not built out of tiny, hard bits in empty space. It is more like fields with stable patterns in them. Some patterns move freely, like light. Some patterns hold together and form matter. Some patterns interact so strongly and consistently that they feel like objects. This is where the earlier videos connect. Light showed us that something real can be a moving pattern in a field. Energy showed us that change can be measured without being a substance. Matter now shows us that solidity can emerge from stable patterns resisting change. Reality begins to look less like a collection of things and more like a web of relationships. And this is not just abstract physics. You can feel it in your hand. Press the table again. The sensation is still there. Nothing about the feeling has vanished. The table still feels solid. Your hand still stops. But now the meaning of that feeling has changed. You are not feeling stuff in the old sense. You are feeling interaction. You are feeling structure pushing back. You are feeling a balance of forces, so familiar that your brain calls it touch. Now imagine removing that resistance, not weakening it, removing it completely. Your hand would not stop at the table. It would not press against it. It would not feel a surface. It would simply pass through. The table would not feel solid. It would not feel like anything at all. That means solidity was never just inside the table. It was in the meeting between your hand and the table, in the way two structures respond to each other. What we experience as reality is not only what things are, but how they behave when they meet. That is a powerful shift, because the world around you feels like it is made of separate objects. A hand, a table, a cup, a wall, a chair. But physics keeps showing us that the boundaries are not as simple as they appear. An object is a pattern that holds together for a while. Your body is not the same matter from moment to moment in the way you might imagine. Atoms move in and out. Air enters your lungs. Food becomes tissue. Skin cells fall away. Molecules are exchanged constantly. And yet, the pattern remains. You still feel like you. A candle flame is similar. The material is always changing. Wax melts. Vapor burns. Hot gases rise. Light and heat leave. But the flame keeps a recognizable form because the process maintains a pattern. Matter is more stable than a flame. But the lesson is similar. What we call a thing is often a pattern that persists. A table persists longer than a flame. A rock persists longer than a table. A person changes more than either, but still holds a recognizable form. So maybe matter is not best imagined as dead, solid stuff. Maybe matter is organized persistence, a pattern that stays together long enough to resist, interact, and be recognized. Now think of a crowd from far away. From a distance, the crowd can look like one mass. It can move like a single thing. It can block a street. It can form a shape, but up close, it is made of individuals, each with space between them, each responding to those around them. The crowd is real, but not because it is one solid object. It is real because the pattern holds. Or think of a ripple in water. There is no separate object called the ripple that you can lift out and place on a table. The ripple is a pattern in the water. It moves, it carries energy, it interacts with other ripples. It can be seen, measured, and felt. It is real, but it is not a thing in the ordinary sense. Matter is not exactly a ripple in water, but the analogy points in the right direction. Reality is full of patterns that are real because they behave consistently. And matter is the kind of pattern that holds together strongly enough to push back. This is why the word solid is both useful and misleading. Useful because in everyday life, tables are solid, walls are solid, rocks are solid. You should not try to walk through them. Misleading because it makes us imagine matter as full, continuous substance. But physics shows something stranger. Matter is mostly empty space, structured by fields and interactions, stable enough to resist change. And that resistance is so reliable that we build our entire lives on it. Every step you take depends on it. Your foot does not pass through the ground. The ground pushes back. Your bones do not collapse under your weight. Their structure resists compression. Your skin can feel pressure because its structure changes slightly and sends signals through nerves. The world feels solid because countless interactions are happening all the time, balanced so perfectly that you never notice them. That is one of the quiet miracles of matter. The ordinary world feels simple because the underlying complexity is so stable. So what is matter, really? Matter is not solid stuff. It is not tiny, hard balls packed together. It is not a substance in the simple, everyday sense. Matter is stable structure in fields, a pattern that holds together, a pattern that resists change, a pattern that can store energy, transfer energy, push back, bend, break, vibrate, heat up, cool down, and interact. Matter is what happens when the changing patterns of reality become stable enough to feel like things. So when you place your hand on the table one last time, let the feeling return. The pressure, the firmness, the certainty. It still feels solid, but now you know that solidity is not simple. It is not contact, not substance, not fullness. It is interaction, resistance, structure, holding its shape. And once you see that, the world starts to look different. Every object becomes less like a lump of stuff and more like a pattern that has learned how to persist. Every surface becomes a meeting place of invisible interactions. Every touch becomes a reminder that reality is not made of solid things in the way we imagined. It is made of fields, energy, relationships, and patterns. Patterns that hold together long enough to feel real. Patterns that push back. Patterns that give the world its shape. Subscribe for more soft physics, a calm way of understanding reality.